Okay, welcome to part C of session 14. Okay, now I'm going to talk about a particular pollution example and how the government might get involved to solve this externality. First of all, the last part I talked about the Coase theorem and what happens that for the Coase theorem to work, we need the transactions costs to be very low. Okay. Uh, Otherwise the people can't, it's hard for them to make a bargain. Now in general we think that when the pollution or the externality involves lots and lots of people, so it's like a factory that's emitting pollution, that's this town of 100,000 people. It's the Coase theorem could solve that problem, but it would involve each of those 100,000 people making a separate agreement with that factory. And this is a lot of bargaining when there's 100,000 people involved. And we might say in this case, the transactions cost would be high in this case, and the Coase theorem might not work. Okay. So what happens when the Coase theorem does not work? Well, often we economists, we say, well, this is a room where, you know, maybe we need the government to get involved, and maybe the government needs to solve this externality problem. Okay. So here's the case. And the example, I'm going to examine table 10.1 in your book. Okay. And so what this is three factories, all in the same town. And the way it works is they are emitting yuck. Okay, we can call it pollution, but the book calls it yuck. And we have three factories, A, B, and C. The first factory, A, is emitting 15,000 units of yuck. Okay. Factory B is emitting 30,000 units. Factory C, 45,000 units. Okay. Now, we want to diminish this yuck. Okay. Now, it's costly, though, to diminish this, to reduce the pollution. And we're going to assume that factory A can do it more cheaply than factory B, which can do it more cheaply than factory C. So in particular, so if factory A is going to reduce its yuck, it can do this at $1 per unit. Okay, so it could totally eliminate all of its yuck. It's 15,000 units by paying $15,000. Okay, factory B costs factory B $2 per unit of yuck to get rid of it. So if it wanted to get rid of all 30,000 units of that yuck, it would cost 30,000 times 2 or 60,000. Okay. All right. So you get the idea. Okay. Now, we're going to start off. I'm going to look at about 6 or different strategies for doing this, 6 or 7 different ways that the government could do this. The first 4 are what we call command and control. Okay, and those are distinguished from other cases where instead we might use taxes or subsidies, or the last case I'm going to look at is an emissions market. As an alternative to command and control. But the first 4, this is the simplest way to get rid of the pollution. This is where the government just acts as a dictator. It just tells the companies, look, you reduce your emissions by this amount, company B, you reduce by this amount, and so on. Okay. So here is so strategy 1. Okay. This is just a new law, and in this law it says no factory can emit more than 15,000 units of yuck. Okay, what would happen if that were the law? Okay, first off, if that were the law, A doesn't need to do anything. A is only emitting 15,000 units. So it's already in compliance with the law. It doesn't need to do anything. So A suffers no costs. Okay. What happens to B? B must reduce yuck by 15,000 units. Okay. It's emitting 30,000. The law says you can only emit 15,000. The difference is 15,000. So it has to reduce it by 15,000. Let's reduce yuck by 15,000. This costs 15,000 times $2, $30,000. C must reduce yuck by 30,000. Okay, it's emitting 45,000. The new law says you got to get that down to 15,000. So C must reduce yuck by 30,000. This costs 30,000 times 3, 90,000. And so total cost for this strategy is, did I do this right? 90,000 plus 30,000, 120,000. Okay. All right. As we're going to see, there's a more efficient way, a more efficient law, a cheaper way to reduce the same amount of yuck. By the way, so each of these cases, what I'm going to do is we reduce the total amount of yuck by 45,000. So we did 15,000 from B, 30,000 from C. Okay, we're going to keep that up. All of these strategies, we're going to try to reduce the yuck by 45,000. Okay, so that is strategy 1. Okay, and let's try to remember that. You can rewind on your video, but let's try to remember 120,000 was the cost for strategy 1. Okay, now let's consider strategy 2. And in this case, what we're going to do, new law, and it says each company must reduce yuck by half. Okay, so that means A will reduce its yuck by 7,500 units. A reduce yuck by 7,500. Cost equals 7,500 times 1, so $7,500. B, let's reduce yuck by half of that, by 15,000. Cost equals 15,000 times $2 equals 30,000. And then C, let's reduce by 22,500. Cost equals 22,500. Let me check this. This is going to be 67,500. And total cost in this case It's going to be 7,500. That's going to equal 75,000 plus 30,000. Total cost is going to be 105,000. So this is actually a little bit cheaper. This is a little more efficient than strategy one. Okay, notice way we did this. The key is to impose more cost on the low cost, the ones who can reduce the yuck by more cheaply, but with lower costs. That's A and B. That's the key. Okay, if you can do that, you're going to get a more efficient outcome where the total costs are going to be less. Okay, so that is strategy two. Okay, now let's try strategy three. By the way, all of these so far, strategy one, strategy two, both of these are command and control. So the government just tells the company, you are commanded to do the following. Okay. Strategy three. And in this one, each factory, reduces yuck by 15,000. So if that happens, A's new amount of yuck that it, or A reduces by 15,000, cause equals 15,000 times 1 equals $15,000. Okay. By the way, note that all three of these cases reduce the total amount of yuck by 45,000. So each factory is going to be 15,000. We have three of them. 3 times 15 is 45,000. Okay. B reduces by 15,000, just like A. Cos equals 15,000 times 2, 30,000. C reduces by 15,000, cos equals 3 times 15,000, 45,000. In this case, total cost equals 45,000 plus 15,000 plus 15,000, and that is 90,000. Okay. So even less. The total costs are even less than strategy 2, which was less than strategy 1. Okay. Now for the final command and control strategy, we'll call this strategy 4. So in this one, tell A to reduce by 15,000. Tell B to reduce by 30,000. Tell C you don't need to reduce at all. Okay, so C gets a break in this case. Okay. What happens? A reduces by 15,000, cost equals 15,000 times 1, 15,000. B reduces by 30,000. Cost equals 30,000 times 2 equals 60,000. And total cause equals 75,000. Okay. All right. Strategy 4 was the least costly way of all 4 strategies. We're going to call that the most efficient strategy if you're going to adopt a command and control strategy. Next, I'm going to look at what I'm going to call strategy 5, 6, and 7. 8, 5, 6, and 7. So 3 more strategies. These next 3 strategies are not going to be command and control. These are going to be, instead, we're going to use taxes or subsidies, or we're going to, the third case, we're going to set up a market where we can buy and sell uh, uh, rights to emit, tradable permits to emit. Okay, so this is part C. Okay, I think I'm going a little bit long here. I'm on 40 minutes. This is about 55. Yeah, part D, I'm going to go longer. So this session, I'm going to go long. Hopefully, the next session, 15, I can go short. Okay, but we'll finish that up. I'll talk about those remaining 3 strategies in part D. Okay, see you there.